Hello.
All right.
Yo.
Welcome.
How y'all doing?
Let's hear it for the for the Melbourne VMUG. I don't see like a.
By the way, that is like punching the oil. Hey, earlier on, who was in the session they did earlier?
Yeah, we're sitting up here with the mics off going, are you tired? I'm tired. I'm so tired.
So earlier on in the session, that people were like, what's your favorite, Sydney or Melbourne? I go, Auckland.
I'll drop the dime. It's Melbourne. So we are going to get started. We're going to welcome any who trickle in the back door, but you know, this is scheduled to wrap up at 5:35. I've got to land the plane at 5:35. You're welcome to entertain them all night long.
I'll correct everything that Vaughn says once he leaves.
So if any of you don't know, I want to say it is a privilege for me to be on stage with my good friend, Chad Sakac.
No, my friend.
El Presidente.
Oh, come on, man. It's a pleasure to be on stage with my longtime buddy, Vaughn Stewart. We've actually known each other for like eons.
Yes, and for some reason people think we like to fight.
Yeah. And sometimes we argue and we debate, but always cocktails at night, guns at dawn.
That's right.
Right?
So what we've got for you today is we were asked to share with you what we presented at VMworld. We've had this little shtick and dog and pony show that's gone on for about 5 years, where we just kind of talk about storage best practices, and we really try to gear it lately towards some of the changes in the industry on the storage side.
And while we're tight for time, historically when we did this at VMworld for the first one, it ran for 2.5 hours because it was the last session. We can't do that tonight.
1 hour session,
right.
And there's 600 people in the room, and they just stayed.
So we're not going to force you to do that now. One quick little interesting comment. Do you remember what was the trigger for the first one that we did? It was the blog post, the multi-vendor blog post. So we were doing a blog post around iSCSI best practices, early days of iSCSI, and the best practices in the VMware guides were not that mature. The vendors were kind of like all over the map. And so we said, you know what, we're all writing blogs and we're talking about these topics separately. Wouldn't it be cool if we actually did one together? So we reached out to the folks at EqualLogic, pre-Dell acquisition, the folks at Left Hand HP acquisition, and we said, hey, let's do one together. And what was weird was I didn't expect, I don't think any of us expected the community. The community went nuts. Because they're so used to, the storage industry is so competitive and hyper competitive that sometimes they're used to basically all of us at each other's throats and that guy sucks and this product is poo.
And the best part is when you're here and people come up, hey, you're going to be in that meeting with Chad, right? Just give them the run. I'm like, nobody's here for that.
Yeah, so this is going to be a cross-industry, which means, if you want to hear about what storage array is the best, come and talk to me afterwards. No. But this is going to be a multi-vendor discussion.
Hey, on that topic, you've been asking me for a while for a pure storage array, and mate,
oh, it's so cute.
I've brought one for you.
Does it scale out?
Open it up and let everybody look. But you know what it does do? It does allow you to add capacity performance without a drop in performance
this is wonderful.
Data migration.
Show
everybody.
Wonderful. Thank you.
Hold it up. So now everybody knows Chad has pure storage.
I have pure storage. I actually do have a pure storage array at home. That's another story.
So let's jump into this. So first and foremost, please tell me you've got the VMUG app installed. Please tell me you've been reviewing all your sessions, because if you like quality sessions at your VMUG, the only way the organizers know what floats and what stinks is if you file or submit a review.
File a complaint.
I am full. I am going to Hey, Darren, I am going to so mess up this presentation after this today. I am saying the wrong words constantly. So anyways, let's dive into the meat. So this is the short version. If you'd like to look at the larger version of this, you can pull down the recording from vmworld.com if you have access. If you don't, I'm sure you know someone like maybe Greg Mulholland who can get access for you.
The foundation, the most important principles have actually stayed almost the same since we started doing this. And the most important one is that storage is the only thing that can really bork your VMware environment. They can take it down and make it have a really bad day. Has anyone had one of those really bad days? When your storage array went boop, did VMHA save you? No. Could you vMotion? No. The only other thing that can cause that much damage is the networking stack, right? So one really important foundational principle that has stayed constant is don't overly complicate things. Keep things simple. Use bigger data stores rather than smaller ones. Avoid RDMs like the plague. Avoid doing anything that basically is a tweak, a hyper-optimization, as opposed to a general best practice.
Yeah, it's funny how many customers will want to ask you about some super secret squirrel config setting, and then you say, but are you using our plugin? And they go, no. And you're like, you take advantage of the tools, because I'm pretty proud of what we've done over the last decade. We were some of the
earliest, and the NetApp side, on the EMC side, we jumped on the vCenter bandwagon really early.
Drove these tools for automation and tools for simplicity, and it's ringing even more true today than back then.
So EMC customer in the room, raise your hand. I want to do something that's going to be depressing for me. Raise your hand. Put it up. Be proud. It's good. How many of you are using the vCenter plugin? Keep your hand up. It looks like it's about half. So that's progress. Every vendor worth their salt that is targeting VMware use cases, and if you're not, you're a crazy vendor, has vCenter plugins. They all have different strengths and weaknesses, but use them. They simplify your life.
Yeah, we've literally built them so that you don't have to go through page after page in the admin guide and start scripting scripting elements. So some other core foundations, and again, this is not going to be a deep dive, but we just want to level set. Make sure you're using features like VAI, elements like atomic test and set, and Xcopy can really make your environment sing. And I'm not kidding you. We had an install within the last 6 months, massive scale install. Customer did not have ATS set, and your mind's kind of blown. They're like, well, we've never certified it in our environment. You're like, this will help your array scale 2x.
So ATS, atomic test and set, basically changed how locking is handled for a whole series of IOs, and is a material factor in scaling. Now, I will say this. I mean, the VAI stuff in the early days, had little bumps, niggles, twists, turns, those sorts of things. One thing that's very difficult for us as you guys as customers, most important thing, and the vendor ecosystem, is people have like legendary stories that like 10 years ago when I did this, it did... and that then gets like a bit set in their brain, right? VMware is a big consumer of storage as a customer, and the team there was like, hey, we use traditional RAID groups, and we're like, why the hell would you do that? Well, in the early days of pools of storage that the array would just abstract that stuff out, there were performance deltas of 5% or more. And then you're like, well, that was 5 years ago, and you're still doing this thing, making your environment artificially complex.
Yeah. Your vendors put a lot of engineering efforts to continue to advance the product. Sometimes you got to pause and revisit their documentation. So that takes us to kind of this nice transition, if you will. All your storage arrays are comprised of the same components. Sure, maybe a disk drive's from one vendor or one manufacturer versus the other, or the SSD, et cetera. But they are, by and large, they're manufactured and comprised of 80% the same hardware components, but they are assembled differently, and where they truly differentiate themselves in terms of how that hardware is addressed and function
is the software stack. So it's really interesting when people go, oh, it's a hardware solution, a software solution. Oh, it's available on a USB stick. It's available in a physical array. All storage subsystems are software. And people who were in my earlier session, we talked about there's different architectural models, but they manifest as hardware appliances or software things. It doesn't really matter. The difference in the ingredients, and by the way, if a vendor's coming to you and saying, pick mine because I have more CPU cycles or cores, or I use this type of drive from a manufacturer or that one, man, oh man, like they're missing the big picture.
So inevitably, what you also have to realize is whichever vendor you have today, whether you're looking at a new platform from that same vendor or you're looking at an alternative platform, you need to revisit the best practices guides, because there are going to be settings that are going to vary in terms of their return on what you set with them with each array. And sometimes these settings will conflict with VMware settings. So in these cases, make sure that you are, right? What do you do?
If VMware says X, storage vendor says Y, what do you do?
Now, who knows that vendor's product better? Would it be VMware, who's got this massive storage ecosystem? Or would it be the vendor itself?
The root of the thing here that's confusing is clearly VMware is the use case, right? So you want to read, and you should start with the core VMware documentation. But it's important to understand VMware writes that documentation kind of like to be average across an incredibly broad ecosystem, as Vaughn said. The other thing that's important to understand is that the documentation is generally synchronized with the tick and talk of VMware major and minor releases, 5.0, 5.5, 6.0, 6.5, right?
Your vendor release is going to follow the tick-tock cycle. It's going to follow their own software release and possibly any changes with the hardware.
Yeah.
So just on this slide, right, you see a number of admin guides or deployment guides, one for each platform.
Yep.
Right? Make sure you visit, if you're going to compare our two products, first off, thank you. But make sure you look at our respective deployment guides so that you know how you can optimize each.
Now there is one tricky thing, which is that sometimes the best practices from vendors conflict. Just be aware of that, right? In those cases, I would suggest that you talk to both vendors if you're a customer that has both platforms. And frankly, if your vendors are worth their salt, their SEs, their technical people will sit down with you and figure out which one of the two is the right setting. There's sometimes stupid stuff like queue depths that unless you have multiple, you've got a UCS customer where you can carve up the VIC into multiple different HPAs, you're going to have to pick one setting that will apply to both.
So let's talk about this. I love this slide. This picture spoke to me when I first suggested we use it, which is you. How many in the room here are totally just storage admins?
That's all they do for their life.
They got 1, 2, 3.
And again, thank you.
Right? So yes, first off, thank you. This means the majority of you, we're going to assume, have some role of either architecting or operating a virtual infrastructure. And you folks have felt the pain as virtual infrastructures have advanced, the pain that traditional storage has provided for them. And that pain's been good because it's led for a number of innovations. But as the market keeps going, it's like, what is the cause of the innovation? Or the pain, I should say, that's led to this innovation? It's the I/O blender. But you hear that term referred to, but mic went off. But what does that mean? So we've shared some of this data in recent months. This is from our phone home capabilities on the Pure Storage arrays that just gives you a profile of what's the real world look like in terms of I/O. Now, yeah, some folks will want to argue about averages, et cetera. But what I want you to highlight here is that each of these vertical bars represent an I/O band based on a range of 10 kilobytes in size. So you go from left to right, smallest to largest. And what you'll notice is one of the smallest bands is the I/O size that's sub 10K. The interesting part is, right, we vendors tend to be guilty of marketing our products at 4K block sizes or 8K block sizes. And what you see in the real world is you very, very rarely, and in this case, less than 4%, see a 4 or 8K block size.
So I'll go one step further so it's very clear on this, right? So again, VNX customers in the room, just raise your hand. There's more than 200,000 VNX customers around the globe. So again, this data set, when you apply it across, it is universal across vendors. It's not a function of the arrays, it's a function of your workloads. This histogram pattern is extremely common. Now, why do the vendors throw out benchmarks with small I/O sizes? Any guesses?
Big numbers.
It's so they produce stupid IOPS numbers, right? And why? It's because sometimes the customers compare spec sheets on the most stupid basis possible.
I want the most memory and the most cores, and how many IOPS? Great.
Right.
It's an easy, I apologize if I offend anyone here, it's an easy way to market your product.
Yeah, but it's stupid salespeople.
Really, really, useless to when you want to put it in place. So
sorry,
with this,
no offense to any salespeople in the room.
So with this, there's a lot of innovation in the market, and we want to just kind of talk to you about it. We're going to break it into 2 buckets. First, we're going to categorize a number of architectures as kind of hybrid, and by hybrid we mean a combination of flash and disk technologies, where the flash is acting as a performance acceleration, a caching tier, and the disk storage is acting as a persistent tier.
Now it's important, there's no value judgment from us here around these different architectures.
We've all either sold or still sell platforms that fit into these models.
These buckets. Now there are material differences, right? The idea that says we are going to cache the I/O before it hits the array, it means that there will be non-linearity depending on whether you get a cache hit or a miss, right? And if that cache is on the array, there's certain behaviors and limits of how that caching algorithm works. Again, not good or bad, this is just a statement of fact, right? And then what we're starting to see is lots of interesting innovation where people are extending the caching layer into the host side. So vSphere read cache, flash read cache is one example. That actually is going to migrate its way into the vSAN code stack over time. Pernix is a really cool example. There were some recent press announcements around Pernix FVP 2.5. But again, what these are doing is they're absorbing IOs before they hit the array. But again, you know, if you do have a cache miss, it's going to need to land on persistence ultimately, right?
And this is the basic building block, as well as we've seen the emergence of now new converged infrastructures in the form of the hyper-converged, right? Nutanix, vSAN, Evo Rail in time, right? Evo Rack.
Yep.
Leveraging all the resources within a server to be a converged infrastructure. And the foundation of those architectures is a flash for cache and performance acceleration, disk for persistent storage.
Now, one thing that is very important for us to just convey is that if something is designed as a hybrid and it has in its software architecture the idea that an IO comes in, hits something that is a cache or a buffer or something, and then gets persisted, if you happen to configure it with all flash media, that doesn't necessarily make it, at least in my mind, an all flash array, right? Because the IO path is still assuming this blended mix. It just so happens, and we've got loads of, this is again, no value judgment, loads of customers with all flash VNXs.
This is the majority of the world.
Right? So on all flash VNX may be awesome for you as a customer, yay, good, or whatever, I'm getting no value judgment. But the point is that that is a all flash configured hybrid, right? The defining element, you know, and that's why I'm pointing it out here on the converged models. We're starting to see configurations of converged offers, whether it's vSAN or others, where you can configure it in an all-flash configuration. It doesn't mean that it's good or bad. I think ultimately, I don't think either of us would disagree on this. Ultimately, NAND is a fantastic persistence media.
Yeah.
Right? And cost of NAND as it continues to decline means you can hit a ton of use cases. Yeah. However, there is this other category which are pure all-flash arrays.
Well, yeah, and one point I would want to make before we pivot to all-flash, understand that every storage array will provide or produce high performance. They're going to be tiered based on the amount of hardware that's in the array, and you know, there's going to be variances based on, you know, the array design architecture and your workload. You can achieve high performance with all of them. What you have to realize, though, is your performance is going to be bound based on the size of your working set and that cache. And the inconsistency that you see in disk storage systems is when your workload exceeds the cache. Whether it exceeds it over natural growth of the data set or variances in the workload is going to be case independent. But this is kind of the state of the union. So it's not a bad architecture, it's a good architecture. It's a cost-effective architecture. But what we are seeing is advances in software starting to lead to and now a change in the industry. And this is affecting all of these architectural models by and large, which is flash as a persistent tier. And as Chad pointed out, there's a difference between sticking flash into a disk-based system that still has the notion of caching and flash as a cache and then dumping to flash as a persistent tier, and all flash arrays that have been designed from the ground up to basically have no cache. Now everything's always served from flash because it's basically persistent memory.
And this market segment, again, is perhaps one of the fastest growing of all the segments. Right?
You guys said the fastest growing of any product you've ever had.
So just to put it in perspective again, thanks, dude. So, you know, who here thinks VMware is awesome? Everybody? Awesome, like freaking awesome.
Was it two hands?
Literally, when VMware was acquired and then wisely let to run completely autonomously, I don't want to imply anything other than that, right? Run autonomously. It took them a total of 5 years to hit $1 billion in revenue. Extreme IO went from 0 to 1.2 billion in a year.
See, right? We have this rule, we're not supposed to product name drop here.
Oh, sorry, dude, sorry. But I'm just going, the point being, forget, just to be clear, that isn't just growth, like absolute growth, yay. It's actually interesting because we're seeing cannibalization and transition in the marketplace, right? So in any case, let's keep on trucking.
Yeah, and I would love to share with you what we're doing on Pure Storage, except for we're privately held, and maybe at some time in the near future, maybe we'll share some of those data points.
You guys have talked about some numbers.
We have talked about some numbers. Last calendar year, we replaced 500 VMAXs. That's 2 per workday.
By the way, just to be clear, you know what? We replaced 1,000 VMAXs with Extreme IO.
Hey. So what did you learn? Everybody's moving from disk to flash.
I wouldn't say everybody. By the way, just to be,
Let me rephrase.
Yeah.
Performance workloads are moving from flash. From
Performance
disk to flash.
workloads that don't need esoteric specific data services. Things like SRDF and specific replication approaches. None of the all-flash arrays have yet, but just to be clear, that's not intrinsic. That will change over time, right?
And so what you need to take from this, right? So we've got our friends up here in the front row, right? Josh, Michael, right from with Nutanix. Everybody in the room knows these guys, right? You have an all-flash offering now. You'll continue to refine and develop this, right? Over time, your ratio of flash to disk will continue to pivot and shift, right? And I assure you guys, if you're not looking at flash today, you're doing your business a disservice because you're buying disk storage and you're going to live with it for another 3 or 5 years. I assure you, flash for performance is available today from a number of vendors affordably, and it'll transition into the capacity market as short as next year.
I want to do something that's a little off track. I know you gotta catch your meeting, but so if I say the word flash, what's the idea that enters in your brain? No, what's the word? Like if flash is fast, you're buying it because it's fast, right?
Everybody would just say when we say the word flash. That would be funny.
What do you say? Do you say expensive?
No, he says, I just picture boobs.
All right, Josh, I won't say that on the mic.
Josh Archer wins. Something about mammary glands. I'm not sure, but.
So the thing that is actually interesting is, it can be fast, but it can also be actually described as lowest watts per I/O or lowest watts per gig. It
highest gigabytes per rack unit.
Per rack unit, so densest. The other thing, this is the thing that's a little bit weird and mind-blowing. So who here has bought a USB stick in the last week? Anyone? How big was it? 32 gigs. How much did it cost? How much? Under $20, meaning
Amazon just had a 256 gig USB 3.0, and it was a high brand name. I forget Kensington or something like that.
Or PNY Corsair.
It was $60.
So what the F? So that means it's already well below $1 a gig raw capacity before you apply data reductions. Now the reason for that is NAND comes in all sorts of forms, right? So the form that shows up in the thumb drives are basically rejects. Like they've got lots of failures, lots of errors, and that's okay because they know that in all likelihood, before you read and write to the cells enough that they degrade that you have a problem, you're likely to lose the thumb disk and just buy another one, right? But the point is that you could apply that form of flash for capacity dense NAND. In other words, for archives, for backups. People never think of NAND for that stuff, but trust me, lots and lots of interesting stuff going down.
This train is on the track and it's coming, folks.
So let's keep trucking.
Okay, so why did we talk about hybrid arrays and why did we do, for lack of a better term, a little song and dance about how well our all-flash products are going is because the emergence of the flash market has re-emerged this concept of how do I benchmark these things?
Lab queens, the massive configurations of mega performance.
So I found this image and I thought, this next two slides summarizes something that frustrates me to no end.
Yeah, me too, man.
If this image represents your business goal, you guys are in the Formula One racing business, you run Grand Prix, your job is to win this race against other Formula One racers, to win on this track or wherever it may be, and then your engineer says, here's how I'm going to test it. I don't understand the correlation. And there's going to be a subset of you, I'm going to guess a third in this room, that go, testing it on the beach is valid. I mean, I want to know the outer boundaries. And
how will it work on a sand surface?
In a mountain range? Yeah, I would do that. And then Chad, of course, is going to go, I was running down my frozen lake. I just want to let you know, it was pretty cool.
And by the way, what I'll do is I'll run the test of the car on the frozen lake, and then I'll compare it on to a minivan on a beach, right? So, this happens all the time. When you go online and people go, I ran this test on this array, people go, aha, that is now a valid data point, and I'm going to compare it against something totally different. Yeah. Benchmarking is actually really, really hard. Now, if you're going to do it, there's some principles.
Yeah. So first off, take input from all your vendors, but if you're going to fall behind one as the gospel truth, let me just tell you what the end result's going to be. that vendor's product's going to have the best results.
It's going to be awesome. So what I've basically found is that the best practice in my experience, just again, because, you know, hey, look, I'm a customer too. I'm an individual. I'm an IT practitioner like you guys as well, is frankly listen to each other. So talk to your peers.
And a lot of you are really smart folks.
Yeah.
So while your different vendors are coming in and giving their tests, have a lunch. Have your 2 or 3 or 4 different SEs sit down and say, guys, I'm going to boil some of all these test suites together. Let's talk about what, where, and why. For everyone who says pro, they should be able to articulate the point why. And for everyone who says con, they should be able to do the same.
Yeah. Now, the other thing that's very important is that you need to do these over time. Systems are nonlinear. When somebody runs a test for an hour, you will not necessarily see the behavior that you'll see in practice, right? So first things first, you're going to start to hear a list and you're like, wow, this is so hard, I'm never going to benchmark. You need to run a benchmark for potentially days to see how systems behave over time, right? The second thing is that you need to think about load generation with an incredible degree of sophistication. So first things first, your tools vary, like so people use Iometer or Slob. You need to realize all of them are intrinsically artificial workloads. You need to configure them extremely sophisticatedly, lots of workers, lots of different I/O sizes if you want to have the I/O blender. You can't do it from one host hitting one array. Why? In fact, sometimes even worse. Sometimes it's one ESX host, one VM hitting the array. That is not like your environment, right?
And remember, a lot of folks want to find the outer boundary on performance, but they forget that there are capabilities like data services or data protection, encryption, and things of that nature
Or the thing
that are
that
going to impact your results.
Yeah.
So to go to just a raw benchmark has no basis in reality. So what we would suggest is, yeah, benchmark your performance test. Take everything that we shared with you on the previous slide into consideration, whether it's an artificial workload, whether it's a copy of your actual data. I think we would agree, the more close you get to your real data, the more you're likely
the more valuable it is. Because
Yeah.
the purpose of the benchmark more than anything is this going to meet my requirements?
Right.
Right?
Then make sure that you haven't stripped the data services off of the storage array. And I will admit to you, this is probably the #1 crime you see, which is someone says, I'm an engineer, I just want to find the outer boundaries. If you're going to run it with snapshots or data reduction or encryption, whatever it is that's your normal operations, you must test that. In addition, you must test your failure domains.
What is it like when I remove a controller, fail disks, fail paths?
Right. True story, and it happens, I'm sure, for both of us. As you start to adopt more Flash through this year and then the following years, you will open a support case when your storage array has 1.2 milliseconds of latency.
Never.
You may have gone from 20, but you'll open a case when it's not hitting sub 1.
Yeah.
Right? It's almost absurd, but the bar gets set. So with that notion in mind, you have to understand, what do I have to do to distribute load to make sure that if I have to take a maintenance window or if I've got a failure, well, what do I have to do to make sure that the performance level is acceptable to the business?
The other thing that is insanely frustrating, because again, these systems are not always totally linear, is if you buy an array that has 20 terabytes of capacity, because you're going to have 10 or 15 terabytes of capacity post-dedupe and data reduction, all that sort of stuff, and then you put on like a gig worth of data for your benchmark, that is not a good test.
I had an SC call me one time and he said, hey, we're competing against an all flash array and things don't look good right now. I'm like, well, tell me what's going on. He's like, well, we connected a Windows host and we just transferred a 1 gig file across the pipe and it was faster on theirs than on ours.
I copied a file.
A 1 gig file, and I went, mate.
Yeah.
Like, would you get towards a workload that has multiple hosts and multiple I/O transactions, and
so
let's
again,
do the customer some valid research on their behalf?
By the way, if you think we're talking about something ridiculous, literally the next time you see someone share their performance test on the interweb, go and take a look and ask these basic questions, and you'll find it's these crazy, stupid scenarios. And then people basically make decisions off the basis of that. It's crazy. Now, this stuff here is an example, and this is a great IDC paper. It was good, had some flaws. worked across the vendor community. It's been updated and better.
Yep.
You know, another thing that is really important is, again, data services on. There was early stuff that said don't use reducible workloads. Why would you build an artificial data set that is non-reducible, meaning doesn't apply to dedupe and compression? If that's your data set, then that's what you should test on.
Yeah, if your vendor has data reduction services, they're giving you value in terms of letting you address more of the resources.
Yeah.
Trying to disable that to validate a test it doesn't stand to reason. So let's move to the next chapter.
So watch this. Quick question. Who here is using any form of IP storage? Raise your hand.
iSCSI
iSCSI or
NFS,
NFS.
about half the room.
Who says jumbo frames good?
Hands up.
Sometimes, yes.
Who says jumbo frames bad? Who says it depends? Yeah.
Yeah, the engineers.
Yeah, engineers. So we for years have been saying
Keep it simple.
keep it simple, jumbo frames off. And people literally would be throwing like tomatoes, and we'd get like blog posts. You guys are idiots.
Look, Sydney was a complete failure on this, so we've just set you up. Somebody in this room step up and write a blog post after this saying, Chad and Vaughn are out of their head. What do you mean? No jumbo frames. Otherwise, it's over and we won't talk about it anymore.
So
It's the great jumbo frames debate.
exactly. There used to be debates about NAS and block, and now it's this one.
Look, what we know in the industry, from VMware through their storage partner community, every storage protocol is more than capable of meeting your enterprise class I/O service levels.
Anyone who says you can't deploy on iSCSI, performance will be bad. Deploy on a fiber channel. Walk away slowly.
Yeah.
Right.
If you're hearing that FUD, just find a better vendor.
Right.
In terms of iSCSI or jumbo frames, IP jumbo frames, what we find when we poll all the vendors, we poll multiple tests inside and outside of VMware customer communities, is consistently inconsistent results, varying between no gain and maybe at the high end 15%.
Now here's the downside. Has anyone in the room ever had a severe outage caused by the MTU fragmentation problem on their IP storage network?
Okay.
Look around the room here,
Look,
guys.
Keep your hands
Right,
up,
keep your
right?
hands
This,
up.
this
Everybody just
is
look
like
around.
AA. This is good for us to admit.
These people, for the pursuit of maybe 15% benefit for some workloads, did something that caused a serious outage.
Does anybody want to bark out what kind of day they had when they had a frame mismatch? Was it a good day? Hold on.
Say it again. Say it again. Say it proudly.
And say, hi, my name is.
Everything.
Yeah.
So what this happened? This happens so sadly often. It's terrifying. Config, load, click, default, resets the MTU from 9,000 to 1,500, and
the worst part is because you have multiple network paths, multiple network devices, multiple LUNs, multiple
trying to
hosts.
figure out which one.
Your day starts off with, I think there's something wrong with VM. No, he says there's no problem. You try to find a needle in a haystack because someone made an infrastructure change, and it is a pain in the butt to identify. And some customers suffer greatly, and others don't. And it's a bad day.
And this is all because someone did a test once somewhere and then wrote a blog post and said, hey, I just changed this one value, and I got 6% better performance.
And you as engineers went,
oh,
I want that. So look, any of you who have it running in bulletproof, we're not here to talk you out of it. What I will say is you cannot deny that we are all humans. We all make errors. Software and hardware companies put a lot of effort in trying to make fail-safe systems so that the humans can't mess it up. You can always mess it up. The new junior admin, you're too tired one night. It's going to happen. And when it comes to infrastructure types of disruptions, they're just so painful that we think you're better off to keep it simple and just roll from there.
Now, by the way, this tech... Yeah, so by the way, if I had my druthers, that's what I would do, right? So the problem is that there are use cases where jumbo frames are narrowly applicable, I agree. And frankly, if I could go back and I could change the IEEE standard for 802.3, man, I'd go down that path.
So mate, in our documentation for Pure Storage, We take it, it's not out of the product, but we took it out of the documentation.
Oh, it's not in our documentation anymore.
We took it out, and in our optimized settings that the web plugin provides, it won't set it.
It will not set it.
So you can still do it, but you're on your own.
Right.
All right.
Okay.
So let's dive into a little discussion here, because data reduction is the new norm in storing your data. Whether your platform currently has it or not, you will be adopting it in the near future. And there's a lot of confusion. Hey, is dedupe and compression the same thing? No.
No.
And for sake of time, let's start with just a couple foundational pieces. First off,
Thin provisioning is not data reduction.
and
It's not that it's bad.
Yeah, it's a dynamic form of allocation. Instead of reserving all the space and hope you fill it up, they'll hold build it and they will come. It just says, okay, you can go that high, but I'm just going to give you storage capacity as you actually use it. The key to this, just like when we talk about 4K performance, benchmarking, is that this value is completely false. Notice the little image here, right? I've got some data in the LUN. The LUN's twice the size of the data.
Hey,
so
I'd like to triple my capacity and triple my efficiency.
Let me just make that LUN a little bit bigger. Tell you what, I'll even make it bigger. Right? Nothing changes in the data, but your numbers go way up. So if you are buying storage from a vendor who's got thin provisioning in their data reduction numbers, I need you to push back and tell them, you need to separate that out, my friend, because otherwise I'm buying vaporware.
Yeah.
Okay?
Again, it's not bad, and I'll tell you a little bit about thin provisioning best practices later, but it's definitely not data reduction. Now, what is, Vaughn?
So data reduction comes in two basic forms, deduplication and compression. And if I were to rewrite this slide, I would say it this way. Deduplication ensures that every block of data on your storage array is globally unique. Compression says every unique block that we now store is going to be stored in a denser format, consuming less capacity.
Now, which one of those do you want? The answer in general is each one has a different amount of effect on different data sets. If you can do both, great. Now, it's important to also recognize that dedupe and compression are not checkbox items. The implementations wildly vary. So again, like on a VNX, there's dedupe and compression. They are post-process, meaning that the capacity goes in, then at some point that process runs.
And you have to schedule it?
And you have to schedule it, or it happens automatically. But even if it happens automatically, it's like a trash compactor. The capacity must exist before you compact. Conversely, things that are doing an inline dedupe basically is like a shredder, right? As you're putting stuff in, you're able to put in more than you would have been able to put in otherwise. Again, we're trying to avoid value judgments, but it's important to kind of go, these are very important because they can have a material effect on capacity and utilization inside an environment, which comes down to cost, density, efficiency, a million things. Dedupe is obviously very important in the VMware use case for broad common images. It's very important in VDI use cases. Yes, linked clones continue to improve, but there's times where operationally you can't use a linked clone. Compression is very, very useful for things that are oriented around database use cases, but so is dedupe, because no one ever has a single copy of a database. Invariably, they have test and dev copies of databases where dedupe can apply a great deal.
And this is one of those technology areas that is actually a good example of what we cited a few moments back. Some of you in this audience will say, look, I tried that before with another vendor, and for the love of God, we're never doing that again.
Yeah.
Technology advances forward. If you're looking at a next generation platform from us, from our friends here at Nutanix, whoever it may be, you owe it to yourself to kick the tires on their newest and latest form of data reduction.
Yeah. The one thing that is an interesting thing about these is there's certain things in array architectures that are very difficult to change mid-life, right? So architectural change from clustered to scale out is a very difficult thing to do properly. It's possible, but it's difficult to do. Trying to add inline behaviors of dedupe and compression is architecturally really hard because it's deeply related to how the data is stored in memory and metadata and in the persistence form. It doesn't mean it can't be done. It just is one of these things that's difficult to add after the fact.
And one thing I should share with you that we don't have in this slide, sorry, I'm going to ad hoc here. Yeah. How many people in the room are not aware that flash devices have finite life cycles? They can take finite writes, right? Isn't that the big, oh man, flash is going to wear out, okay?
Yeah.
How you reverse that trend, and specifically why flash devices are rated for so many writes per day, is when you stick them into a disk-based system. Sticking a flash device into a disk carrier where there used to be a drive is how the industry looks to say that is the worst possible situation for a flash drive, and thus they have constructs like write amplification, and they take that factor and put it into the lifecycle ratings. So when you stick that into your storage array from your vendor, it behaves the same way. That's why folks build new systems from the ground up, so that we can reduce the writes by making sure that only data that's globally unique hits the flash.
And it's written as efficiently as possible.
So that you don't keep writing data over and over again, so that that flash media has a longer life cycle. That's it.
We have 5 minutes, so we're going
5 minutes. So
super simple on this one. Thin provisioning isn't intrinsically bad. Understand how VAI unmap works. There's some specific commands and operations. It doesn't work the way people expect.
still not end-to-end through the VM.
It's not end-to-end through into the guest OS. There's some specific commands to run. It takes some time for that operation to occur. This improved in 5.5U2. It's even better in vSphere 6, but it's still not the way that people ultimately think it should operate.
Next up, vVols coming hot and fast middle of this year, right? We're going to be in vSphere 6. I think we both would agree, and I think most of you that we've spoken to today agree that it's something a lot of us will be looking at through the latter half of this year and planning for implementations next year.
It will radically improve and simplify how people run and manage storage.
So make sure as you're going through the year that you're looking at your current vendors and any new products that you may adopt to figure out, are they going to be vVol compliant? Is the hardware compliant? Do I have to upgrade the software? And am I going to need additional capacity?
And there's an extra set of questions I would recommend, which is basically what data services will be manifested through the vVol interface, and what are the maximal behaviors that I can expect from the vVol implementation. But again, just like the early days of VAI, this year, as Vaughn said, is mostly going to be, hey, we're trying, we're playing, we're using. Not because it's not important, not because it's baked, but we learned these things take time to mature, adopt, and deploy.
And what we will share with you is that vendor implementations to meet the vVol specs
will
under the hood
vary.
are very different.
Yeah.
We were on the phone 2 or 3 years ago just talking about, I was back at NetApp and you're at EMC, and we're like, you're doing it that way, I'm doing it this way. Well, we're pros and cons.
And
now if you look at our
NFS-PE endpoints versus, you remember that?
And if you look now at like our newer products, right, they're implemented very different than those disk systems. So just get a little educated on what the capabilities are. Okay, we're going to skip this for time, which was QoS.
QoS, not intrinsically bad, but understand that there's other things that you can use on top, like SIOC is always the thing. I'm amazed more people don't use SIOC.
Obviously, vVols will help us to get some more of that granularity. The big thing with QoS is it's hard to deliver through a clustered file system today because you want it on the disk level. vVols will be an entry point to make that very wide.
Now, one thing that's interesting, when we did this at VMworld, we had Rawlinson Rivera, who's always a funny dude, and Captain vSAN, along with many others. Greg was doing the session earlier on vSAN. In the early days, people had a takeaway that said, if I'm using vSAN, I don't need to know about anything. Right? There are design best practices for vSAN. They're pretty basic. Number one, you should look at the stuff that's on the vSAN ready node list, right? What we found in the early days of vSAN is people would take the vSAN bits and they'd blam it in their lab, they'd play, it would be like, yay, awesome, great, and then they'd deploy it into prod and go, whoa, right? The reason for it is that what you do inside your lab to play for functionality testing is different than what you actually see in prod. So things like what is the maximum queue depth on the controller really matter, right? You need to have more industrial servers and local DAS controllers for the SSDs and for the HDDs that are inside those systems. The second thing is that while you can have vSAN nodes that are asymmetrical, in other words, you could have the vSAN storage pool being on some part of your vSphere cluster versus not, it's not a best practice. You should need to kind of try to aim for everything in the cluster being the same.
Remember, you want consistency. Even if you're having a problem, you want it consistent so you can find it. There is nothing worse than trying to find an intermittent problem.
Now, the last element in this as you're going down this path is just to think about the fact that rebuild time in vSAN is highly dependent on how wide you are with your vSAN pool, right? So go through your own testing as you play with this. It continues to improve in vSAN 6. So again, check it out. Cormac Hogan has got a set of brilliant blog posts on this topic that I'd highly recommend if you're going down this path with vSAN.
Yep.
Automation is super easy. Automate. It's a good idea. Every array, whether it's a physical array or software, has a RESTful API. Anyone worth their salt.
If they're saying I have a vendor-specific API and it doesn't support REST, Move on.
And a CLI is not an API. just to put it out there, right? Now, the thing that's interesting is I'm finding customers, I don't know about you guys, that literally want to get into bar fights over, is it Puppet or should it be Chef? No, I'm all Golang, baby. No, it's Ansible, Salt. No, it's VCO, PowerShell, biatches. No, like whatever, right? Pick the one that is the best for you, where you and your team have got the best degree of confidence, and settle around that, right?
Yeah, and anyone who wants to say, look, there's some way to not get locked into a vendor, every purchase you make, you're locking into that vendor, whether you're deploying Linux guest OSs, Windows, array vendors from
even
vendor
open
XYZ.
source software has a form of lock-in. The ability to move from one Linux distribution to another is actually relatively hard for most customers. Right?
So with this, we need to wrap up because I got to get out of here. So just a couple perspectives, and I think we've shared some of this as we've gone through the last couple minutes.
It seems like hours.
Man, I am saying the wrong thing all day long. You want to go present for me?
Yes. I'll open up your new distribution partner.
Bang.
Deal?
Why are we not doing any business? I don't know. Chad was there.
So look, interesting things. Data growth continues to be enormous. The one thing that's interesting is the bulk of that data growth is not coming in the form of VMs. Just as an interesting little observation.
Unstructured data, folks.
Unstructured data, Dropbox, object, HDFS stores. So if you think this is the only world of storage, hey, there's a lot of other interesting stuff going on out there.
But with that said, you may be deploying lots of VMs that support analyzing, addressing, accessing, mining this data.
Yeah.
So there is a symbiotic relationship here between various forms of storage and your world that's gonna keep you locked in with having to follow what's emerging in the storage space.
There's some really, really interesting stuff that we put out there, which is if you're a vSphere customer using 5.5, there's this thing called the big data extensions. If you want to just have like a fun, interesting thing to introduce yourself to the world of Hadoop, there's a whole bunch of blogs on it. Just basically look for big data extensions, blah, 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 blah.
So if I could give you one principle, we opened this session talking about simplicity and trying to continuously drive the industry towards simpler models, automated models. If the global data set's going to grow tenfold over the next 7 years, whether you agree or disagree, it's fivefold, right? Your staff is not going to increase at the level that your data set is going to grow. Simplicity begets simplicity. Simplicity begets scaling, right? So you need to always be continually evaluating your technologies for simplicity, or you guys are going to drown.
So other interesting thing, we talked about why we think NAND and flash are really, really important. Everyone wants to wonder what's going to replace NAND. The answer is nothing on the horizon. There are things on the horizon, phase change, carbon nanotubes, memristors, those sorts of things that will get added to the persistence hierarchy. They'll be roughly about 100 times faster than NAND, still 100 times slower than DRAM. Yeah. They'll be in the stack somewhere. They'll cost a fortune in the beginning, right? But then they'll change over time, right? Those things will create disruptions. But the disruption is going to be in stuff that's relatively esoteric in the beginning, in-memory databases and stuff like that.
Yeah, for those who want to say, well, spin torque and phase change, and aren't these faster than NAND? Understand first, we haven't scratched the performance potential of NAND first, because NAND is being stuck in the backwards compatible disk systems
in SAS
that
controllers.
have things like SAS controllers that have interrupts designed around disk. When we get to memory optimized controllers, PCIe, NVMe, right, performance will take another tick up. Second, there's a global market for NAND fabrication. This will dominate the economics of NAND for the near foreseeable future. NAND is like Ethernet. Was Ethernet always the fastest network? No.
You want to hear
the broadly adopted network.
So again, we're almost done here, but weird, interesting stats. So the world manufacturing capacity for NAND in 2014 was roughly 22 exabytes. Sounds like a lot, right? 19 out of those 22 exabytes went into what? iPhones and Samsung Galaxy devices. The grand total remaining 3 exabytes was the entire world's manufacturing capacity for NAND that goes into laptops, NAND that goes into enterprise arrays. So it's an interesting thing, and literally it costs $5 billion to create a NAND fab that would add roughly 4 exabytes of capacity. So like this is an interesting thing. People are always wondering like, why don't we just have like everything all on? Well, there's actually literally like a supply demand thing kind of going on. It's very interesting.
Yeah.
if you like that stuff.
With that, while we are in the emergence of software-defined architectures, I think we both fully agree hyperconverged is going to find sweet spots. You know, we think it's brilliant right now in branch offices. Where it grows from there, I think sky's the limit.
Yep.
So watch for that. I think there's architectures like big data that started in the DAS space that we see at scale shift back to shared storage.
It's weird. The pendulum swings and swings back and swings because us as humans, we want there to be one right answer. There isn't one right answer.
Yep.
So I think with that,
I think we're good.
If you guys want to ask questions, I'll stick around. If you got a bolt, please give us feedback. You know, via the session feedback app. And I would love to take questions if you guys have got them. If Vaughn, as long as you can stick around, you're more than welcome.
Actually, I apologize. Now I am supposed to be presenting to a new distribution partners launch event at 6 p.m., so I am going to be late.
Dude, bro.
Thank you. Brother.
Thank you, everybody. If you do have questions, please ask Vaughn.
Yep.
Boogie, man.
Hey, you guys, you got the floor. Thanks.
Oh,
that's my laptop.
Don't forget your laptop. And yeah, I know. So you're gonna give me the cards to draw?
Oh. Sorry. No, that's
So by the way, while we're doing all this stuff here, I think we're gonna have some closing drawings for everybody. That's probably why you've been so patient with us. You're like, guys, shut up. I want my iPad.
Oh, okay, that's all right. I'll look after it.
So first things first. Any questions from that previous session? Yes. So it's really interesting. So the first thing that happens is that with Hadoop, so the question was, why would the pendulum swing back to shared storage with Hadoop environments, right? Now, by the way, when we say shared storage here, we're not talking about a SAN. Just to be clear, right? Not a SAN. Although you would not believe it, some of the world's biggest Hadoop implementations actually run on a SAN device because a single data node failure has such a catastrophic effect that they want literally a HA DAS behind an individual node. Can you imagine that scenario? Like literally if the amount of time to basically do a data copy and redistribution is severe enough, I find customers doing that. Crazy, but true. The other core reason fundamentally is that the HDFS implementations depend on 3 copy. It has the idea of copy within rack, copy across rack as the fundamental data protection mechanism. And HDFS objects are all 64 megs or 128 megs in size depending on the distribution. That's very inefficient compared with erasure coding algorithms. It's not RAID, but basically where data gets parsed and distributed across those clusters. So as they get big, they start to go, holy smokes, I have 18 racks of DAS. I'd like to go denser. The second thing is, watch this. 2U server. Are you a Dell, HBM, Cisco shop? Cisco? So a C-Series 240M3. What's the maximum number of disks you can stick in 2U? It's like 16, right? Rough and tough. 16 per 2U is not that dense. In something like an Isilon cluster, we have 60 spindles in a 4U, or 98 spindles in a 4U. So in other words, literally there's a capacity and also a management question, which is how do I manage the data? How do I distribute it? You never back up a big object store because like the idea of going, I will back that up to data domain or use Symantec to, no, that's stupid, right? But what you do want to do is you want to be able to create copies and replica management of those HDFS objects. So it's all of those drivers that are going down that path. I'm going to do a blog post actually on a customer case study on that. If you read Virtual Geek, you'll see it's really actually pretty cool. Any other questions? Time for the big drawing?
Time for the big draw.
Okay, great.
So this is the vendor draw for the MC. What's the prize?
The prize is absolutely unique. You've never seen one of these in a prize drawing before. We thought about it long and hard. We came up with the creative iPad Mini. Woo! By the way, it's 16 gigs. Are you all right? You ready? So, okay. You know what? Why don't you do it, Tyson? My friend from IBM.
Santosh Simon.
Santosh, you have to be here to win. Okay, I'll do the next one. All right. Okay. We've got a winner. It is Matt Walker. Oh, how did you know, Matt? Nice. Congratulations. Are you a EMC customer?
Yes.
Thank you. Congratulations. All right. Thank you very much, everybody. Much appreciated. You guys will continue the drawings. Thank you. If you have any questions, drop me an email.